చలేవండి. Hello all, this is Monica with my team Sushma and Pavan. Here we're gonna discuss our project CKY Parsing project. So CKY Parsing is linguistics and natural language processing to parse sentences and determine their grammatical structure based on a formal grammar, usually in the form of a context-free grammar. The CKY algorithm efficiently explores the possible parse trees for a given sentence and checks whether it can be derived from the grammar or not. And further will be continued by my teammate Sushma.
Hi all. This is a Java domain questions based CKY parsing table, and we use the Python language here to execute the statements. Uh, for this, the first step is the context-free grammar. The context-free grammar is nothing but it is a set of productions or rules. We have one left hand side we have like one terminal and one non-terminal nodes, and from the right hand side we'll be having like multiple terminals, and whereas Chomsky normal form, that is called CNF, that is the next step we need to consider it. And for that, the leftmost hand side it will be like one terminal or one non-terminal, whereas the right hand side there will be two non-terminal nodes. For that we have done we took like 25 sentences based on the Java questions, and this is called our CFG, that is a context free grammar. This is our grammar, and when we go down, this is our sentences, and these are this is the conversion of CFG to CNF. This is the second grammar we got it. And when we go to the CKY table, the first sentence is like, what is Java language? Okay. The word what we consider this as like 0. This is 1. This is just for a simple explanation. This is 3, and this is 4. So 0 and 1 is about what? So what is nothing but we can see in our grammar. Here we can see the what, it shows like auxiliary. So we just like wrote here auxiliary. When we go down, the 1 and 2 gives is word. So is nothing but like verb. Verb can also be written as VP. And when we go down here, this block, we need to consider these two. So auxiliary and verb. Auxiliary followed by verb, auxiliary followed by VP. We don't have any grammar for that. So it will put it this as empty cell. So now next we'll go to 2 to 3, that is the Java word. We consider Java as a verb here. Here we can see that. And about that, as is the bottom up approach, we'll go from the bottom to the upside. So this will be considered as these two, verb followed by verb. So there will be no grammar for that, and we consider this as an empty set. This and this one, as these two are empty, these two we need to consider. These two are empty. This is also an empty set. And when we go to 3 to 4, that is a language word. For that language, we just have, for the language we have noun. Noun is nothing but nominal. A nominal is nothing but empty. So So we have written noun and NP. For the above this line, we just consider verb and noun. Followed by noun is nothing. It's just we don't have any grammar for that. Verb followed by NP, VP, and VP can also be written as NP. And like the next top second one, which we consider as verb VP and VP NP. Verb VP is nothing but VP, and VP can be written as NP. And the corner one, we can say VP NP is nothing but S. All these grammars are here, right here. So NP VP is S. We'll just talk about the valid sentences because we have S in this table, so we consider this as a valid sentences. So all this we have done in the same method. We also have some invalid sentences, that is nothing but like is Java suggest. The first word here is. We consider is as a verb from the grammar itself. Java is verb, suggest is verb. These two, I mean, like to get this to get this cell, we need to consider verb and verb. Verb followed by verb is nothing but empty. So we consider these as an empty. And verb consider and these two is nothing but empty. So not empty and empty gives you nothing. So there will be no S. So it will be an invalid sentence. The same way we have done the other also. And we just got like a few of the valid sentences and the other are the invalid sentences. The parser code will be explained by Pawan.
Like, hi, I am Pawan. Now here I'm going to explain about the parser code, which we have wrote in the Python language. And the ID used is Python Jupyter Notebook. Here, now I'm going to execute the code. Here, as we can see, oh my God, I didn't share the screen. 1 second, I'm going to share my screen. Here you can see the parser code for our project. Now I'm executing the first chunk. Now execute second chunk. Here we need to enter the sentence, which we like to check whether it's a valid sentence or not. Now first I'm going to check out the first sentence. Sentence able. Like, yeah, the first sentence is like, what is Java language? Let's check this. Like, yeah, as you can see, like it's the S, so it means that the sentence is accepted. In a similar way, let's check the other sentence, like one or two more. Yeah. Second one. Mhm. Yeah.
What is object in Java language?
What is object?
Is object in Java language?
Like, and you can see that it's accepted, the sentence is valid. And now let's check about the invalid sentences, whether the code works for invalid sentences or not. So that
Java suggests.
yeah, let me check about this sentence is Java suggest, and we got the output as no. Here, this indicates that the sentence is invalid according to the given grammar rules. And let's check a few more sentences randomly. Like, tell me one more, please.
How many data types in Java language?
Like, how many data types included? No?
Java language.
Oh, that's cool. Oh. How many data types in
Java language.
is that right?
Hmm.
No. Spelling data types, it's the same word or different word? Choose it is correct.
Even how many types is always similar.
Like
It's wrong.
this is a long sentence.
What is the use of Java
What is
language?
the use of
Java language?
the language? What this is, as we see, the sentence is a valid sentence, and like we'll check one more sentence for invalid one.
Language will recommend.
Language
Will recommend.
will recommend. Will recommend. Let's see what the output is. And it's a no. So that means the sentence is invalid. And in this way, we have checked every sentence, like 25 sentences of valid statements and like 4 to 5 of invalid statements, and we have included that in the project PDF file. Like this is a project, and we have successfully did it. Thank you.
Thank you.